Hi, welcome back from your second break. This is Dr. Matthew J. Traum. This is the third video in the second lecture of the engineering design course. This is the slide that we stopped on when I hit my 7 minutes last time. So this is where we will start moving forward. It turns out this is the final slide in the deck with the exception of the exit slide. So we'll spend a little time talking to this one and then we'll wrap it up. So we've spent a bit of time discussing how the engineering design process is non-linear and non-hierarchical, quite chaotic, not very well structured, and not particularly well understood, at least from a cognitive perspective of how the brain is functioning as humans are doing engineering design. And so the purpose of this slide is to really ask and answer the question, is there need for a systematic design approach? There's a whole class in front of us. Do I really need to keep teaching you guys how to do engineering design, given that by its very nature it's incredibly chaotic and difficult to grasp from an engineering science perspective? So the real question is, given that design is chaotic and non-hierarchical, is it even possible to teach or to learn design through a systematic process? And as we saw before, the answer to that is yes. Engineering design can be taught, even though it's very chaotic. And the reason that it can be taught is because we see again and again in very skilled, very renowned designers, three skills. And we talked about those skills before. The first two are creativity and innovation. Both of those can be taught. That's been demonstrated. And then the third is experience, and experience comes just from practice, which is really part of an engineering design course, is for you to practice doing design so that you get good at it. So we can teach you creativity, innovation, and experience. We can give you those skills, and therefore you can at least have the same skills as a renowned and very successful engineering designer. So that's one positive outcome. The second positive outcome is people have actually studied this question. Psychologists and engineering education folks have studied the question of whether a systematic approach to engineering design actually helps with the outcome. And it turns out that yes, engineering design outcome is positively influenced by use of a systematic approach or process, and you end up with better quality solutions than if you use no process at all. So I've got this fellow here who is buried under a pile of paper. These are, I guess, discarded possible engineering solutions, and he's holding up a sign that says help. And this is really what I want to address with respect to why these studies show the result that they do, that a systematic approach does facilitate good engineering design. So four things. The first is that a systematic process allows the designer to simultaneously manage the problem space and the solution space. As we saw before with a synthetic type approach that a designer would use, you're changing both the solution and the problem essentially on the fly as the design process evolves. And so being able to manage that helps you to avoid this situation where you're essentially buried under a mountain of bad ideas. The second is that it provides a canvas to organize thinking against a chaotic backdrop. So sort of a similar idea, given that the design process itself is chaotic, it does give you sort of a systematic map to use to find your way through this otherwise very chaotic engineering design space. Third is that engineering design encourages quantitative weighting of solutions. So even though there is a lot of creativity and innovation, and sometimes those things can't be quantified, the engineering design process does include a quantitative step, which is down selection, which allows you to select from all the possible solutions you've come up with to select the best one. And that is a quantitative process that you can always go back to and say, this is why I made a particular decision, because I used engineering analysis, engineering mathematics, and a quantitative process to assign a number to various possible solutions and then pick the solution with the highest number. So it does quantify what's otherwise a very chaotic process. And then along the same lines, this fourth point is that having a systematic design approach creates a paper trail, allowing a designer to track how decisions were made. If you don't keep track of why you did certain things, it's very easy to forget why they were done. And then when you get further on in the process, a decision that you made, you might find that that's a hindrance, and you don't remember why you made that decision. Then you got to go all the way back and redesign without guidance from your own thinking and your own process back in the past. So it does provide that paper trail and that history that you can refer back to. So given that we can teach the underlying skills of engineering design, and given the benefits of a systematic design process, looks like we'll continue with the class. So that is my final slide. This has been the second engineering design lecture. Thank you for your attention, and I will see you next time.